Let's talk about how to remember the unit circle. So in the previous lesson, we constructed the unit circle using the special triangles. Remember, we had the 30, 60, 90 triangle, and we had the 45, 45, 90 triangle. And what we did is we took those triangles and we put them on the unit circle, and that's how we essentially constructed it. So to find the angles, so that's going to be the first piece here, what we need to do is calculate what each angle is going to be using those special triangles. So if I were to take these angles and put them in order, I would get 30, 45, 60, 90. And so just using those angles, I can go around, starting with 0 degrees, I can go around and start constructing the angles. 30 degrees, 45 degrees, 60 degrees, 90 degrees. Then from that 90 degrees, 30 degrees, so 90 plus 30 is 120, 45 degrees, 60 degrees, 90 degrees. And you're just adding to the previous value. 30 degrees, 45 degrees, 60 degrees, 90. 30, 45, 60, 90. So now, what about the radians? How do I find what each radian piece is? So in a previous lesson, what we actually did is I showed like how we can take the circle and we can kind of chop it up into those various radians. And that's all we're doing here, is we're just taking the circle and we're chopping it up. And we're chopping it up into two pieces. We're going to chop it up into pi 6 and pi fourths. If we chop it up into those two pieces, then we can go through and construct the entire unit circle. Now, pi 6, we just need to remember a little equivalency. That's 30 degrees, and a pi fourths is going to be 45 degrees. So let's do that first one. Let's chop everything up into pi 6. So if I were to cut that half, every single 30 degrees is going to be a slice. And all I'm doing is just going by 30 degrees around the unit circle, and I'm getting those slices. So for example, one slice would be 1 pi 6. Two slices would be 2 pi 6. But if I reduce that, I get pi thirds. 3 slices would be 3 pi 6. The 3 and the 6 reduce into pi halves. 4 pi 6, which reduces into 2 pi thirds. 5 pi 6. 6 pi 6. 7, 8 pi 6. 9 pi 6, which reduces into 3 pi halves. 10 pi 6, which reduces into 5 pi thirds. 11 pi 6, and 12 pi 6, which gets us back to the 360 or 2 pi. And then we do the same thing with the radian measure for pi fourths. So if pi fourths is every 45 degrees, I'm going to chop this up into 45 degree slices. And so every 45 degrees is going to be a pi fourth. So 1 pi fourths, 2 pi fourths, which reduces into pi halves, 3 pi fourths, 4 pi fourths, which reduces into pi, 5 pi fourths, 6 pi fourths, 7 pi fourths, and 8 pi fourths gets us back there. The next piece is going to be the sine and cosine values. Now, the way that we need to look at it is the cosine value is the x value, and the sine value is the y value. Now for the boundary points, because this is on an x and y plane, the radius is 1. That means one space this way would be 1, 0. One space up is 0, 1. One space this way is -1, 0, and 1 space down would be 0, -1. We're just, if you think of it as a coordinates plane, we're just moving 1 spaces up, down, left, and right. Now what about these values? How do I memorize those values? Well, let's look at a few characteristics that they have in common. The first is going to be they're all divided by 2. Every single one of these is divided by 2. So all across the board, they're divided by 2. The second thing, they're all under a square root. Every single value is under a square root. Now I know what you're thinking. You're like, wait a minute. That 1 is not under a square root. Well, what's the square root of 1? 1. So it's just a square root that's been reduced. And so instead of writing it as square root of 1 over 2, we just write it as 1 because the square root of 1 is 1. And then the last little piece is going to be, how do I find those values on top? And so as long as we just know this first value right here starts at 1, that's my sine value or the y value, that starts at a 1, all we have to do is think back to kindergarten and some basic counting. 1, 2, 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. So we can count up to 3, 1, 2, 3. We can count down from 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. Then how do we find the cosine? Well, if that's 1, then that's 3. When they're 2, they're the same. When that's 3, that's 1. They just kind of like flip. Now the last little piece here, and I'm just going to close with this, is the positives and negatives. The positive and negatives follow what they normally would for an XY graph. For example, the x values, right? So in this case, my x and cosine values on this side of the x-axis are positive. So that's why all of my x values are positive. On this side of the x-axis, they're negative. That's why all of my x values are negative. For the y values, they're positive here. My y values, they're negative down here. And so that's why all the y values are going to be negative down there. And then if you just remember cosine and sine, cosine is x, sine is y. This is essentially the tools you needed to memorize the unit circle.